So for number 15, it starts us right off with a fraction, nothing being added or subtracted to the fraction, just the fraction itself. So what we're going to do is I'm going to multiply both sides by the denominator. So I'm going to multiply this side by 1 plus 3e to the x, technically over 1, and this side by 1 plus 3e to the x over 1. So, because what happens is then these two will cancel and leave us with just 20. And the right-hand side, we're going to multiply, because you can make that 4 over 1 if you want. Multiply the 4 in there. 4 plus 12 e to the x. So we're going to subtract the 4. Then get 16 equals 12 e to the x. And then we will divide both sides by 12. So I'm just going to reduce that for right now, but still keep it in a fraction. So divide both sides by 4, get 4/3 equals e to the x. So we're trying to solve for an exponent. So we need to undo this exponential expression to get that x down here where we can solve for. So we need to undo that e, and this becomes then natural log of 4/3 equals our x. By bringing that over, it undoes that e. So ln natural log of 4/3 0.288 we'll go with. So x equals 0.2, and we should do approximately 0.288. And remember, when you guys are solving for these, you should have a calculator for these problems. You can always plug that exponent back into your problem. If you do 20 divided by the quantity 1 plus 3 times e to the power of 0.288. Now, is it going to give you 4 exactly? No, because we rounded that decimal, but it should be close. Like it should be 4.001 or 3.98. It should be pretty close, at least give you an idea of if you did the problem correctly or not. So let's go over and look at 16. E to the 2x minus 8 e to the x. So if we tried factoring this, remembering our exponent properties, x times x gives us x squared. But when you multiply things a power, if it's a power x times a power x, then you would have 2x. So if we were trying to multiply or factor this out, what multiplies to get you -9, but adds to get you -8, so it would be -9 and plus 1, but it would be e to the x and e to the x. E to the x times e to the x would give you e to the 2x equals 0. So we don't know how to solve when we have 2 e to the x's. If there were just one e, we could undo that. So we're going to do something here we've never done before. We're going to use substitution. I'm going to let u equal e to the x. So wherever I have an e to the x, I'm going to substitute in u. So this becomes u minus 9 and u plus 1 equal to 0. So if you guys solve for these values, you guys would know u would equal 9 and u would equal -1. Well, we're not trying to solve for u. We're trying to solve for this e to the x thing. We're trying to solve for our x. So we need to substitute, now that we have a single value, two little mini equations, we can substitute e to the x back in here and go from there. So we can say, okay, x is going to equal the natural log of 9, whatever that value is, and x will equal the natural log of -1. Well, if you guys try to take the values of those two numbers, you can't take a natural log of a negative value. You can't take a log of any negative value. So our only answer is this natural log of 9, which when you guys type it in, gives you about 2.197. So let's look at the word problems. So it says you save $1,000 from a summer job and put it in a CD earning 5%, compounding continuously. So how many years will it take for your money to double? So we're saving 1,000, we're putting 1,000 in, but we want it to double. So we want our end amount to be $2,000. We're compounding continuously, so we're using that PERT. But our initial value is that $1,000. We're just wanting it to double. Times E to the power of your rate, which is 0.05, times the time, which is what we're trying to figure out. So 0.05 t. So we can divide both sides by 1,000. And get 2 equals e to the 0.05 t power. So we know how to undo this now and solve for this. We know that to undo that e, we can bring this over and take the natural log of 2 equals 0.05 t. So you could type natural log of 2 in a while, or you could say the next step would be to divide by 0.05. And whatever that gets you your t. So we can do that in the calculator. Natural log of 2 divided by 0.05. Natural log of 2 divided by 0.05. So 13.86 years. So about 14 years. Just a little under 14 years. For your money to double if you put $1,000 in there. So how about 18? If money is invested in a savings account earning 4% interest compounded quarterly is your end value. So we're using that A equals P times 1 plus R over N to the power of N times T. How many years will pass until the money triples? So $3,000, not $3,000. So we don't know what we're actually putting in. We're just trying to figure out how much time will it take for it to triple. So we don't know the principal or the starting amount. So 1 plus, but we do know the rate is 0.04. And it's quarterly, so 4 times a year. And we're trying to figure out that t. Okay, so we said we don't know the principal, but we know we want it to triple. So whatever that principal is, we want it to be a value of 3 times that much. So we can just say 3p. So you're probably thinking, well, we've got 2 variables. Well, that's okay, because if you got a p out in front of there, the first step would be to divide by p. And what happens is they actually cancel each other out on both sides. So then you get 3 equals just 1 plus 0.04 over 4 to the 4t power. Okay, so let's we have to undo this exponential piece. Like we would need to take the base of this and bring it over, but we don't know that base yet, so we have to get the value of what is underneath, or not underneath, what is inside those parentheses. So 1 plus 0.04 divided by 4. When I type that in, let's actually get a better decimal. I'll round it to 3 or 4 places. So 1 plus 0.04 divided by 4. Oh, that's why I only wrote 1.01, because that's what it is. All right, so 1.01 to the 4t power. So to undo this exponential base, we're going to bring this over and it becomes a base for your log, which is fine. Log base 1.01 of 3 equals 4t. So how do we solve for a logarithm? Like you guys would know, log base 2 of 8 would be 3, but if it's a decimal, we're just going to use that change of base formula. So natural log of your arguments, so natural log of 3. Just going to keep on moving over here. Divided by your natural log of 1.01 is going to equal 4t. So ln of 3 divided by ln 1.01. So we get 110.41, and the next step would be to divide by 4. So I'm just going to do that now while I have the calculator out. So divide by 4 and get 27.6. So time equals 27.6 years. So why don't you guys try number 19? Pretty similar to what we kind of just did for number 18. And let me know if you need help.